Hello, my dear student from Karnataka board, PUC second year. Today I am going to discuss with you the chemistry questions of model question paper. Model question paper of Karnataka board. Now, it is very important questions with respect to the for the those students who are appearing in this year 2026 for the PUC second year examination. Now, I am going to discuss with you the first of all the MCQ questions of the model question paper. It is very important because this question directly come in your final board examinations from here model question paper. For your confirmation, I tell you, for your belief, if you want to match your pre-board questions, maximum and maximum more than 10 questions are directly from the model question paper. That's why this model question paper are very important. Now see one by one questions. First question is given here. The common oxidation state shown by the element with atomic number 21. Atomic number 21, as we know, the atomic number 21 is scandium. Atomic number 21 is scandium, and oxidation state, common oxidation state of scandium is +3. As we know, first group of D block elements of +3 and the last +2, that is fixed oxidation state. Apart from that, remaining all the transition elements of variable oxidation state. And this is first group, that is scandium, as scandium, yttrium, lanthanum, so +3 oxidation state only. The answer of first question will be A. Answer will be +3. Next, which of the following is homoleptic complex? Homo means same, leptic means ligand. Homoleptic complex means same type of ligand present in which complex? As we know, ligand is present inside the big bracket. Inside the big bracket, one is central metal atom. Apart from them, this central metal atom is surrounded by ligand. And here, how many type of ligand? Two type of ligand. One is ammonia, other is chlorine. This is not homo, means same ligand is not present here. That's why it is heteroleptic. This is heteroleptic. And we see here, one is central metal atom, and central metal atom is surrounded by, this is central metal atom is surrounded by ligand. 5 ammonia and 1 chlorine. This is also heteroleptic, two type of ligand. One is ammonia, other is chlorine. If we see next question, inside big bracket, there is central metal atom, and this central metal atom is surrounded by ammonia and water. This ammonia and water are different type of ligand. That's why it is also heteroleptic ligand, heteroleptic complex. If we see here inside big bracket, not outside, this is ionization sphere. In ionization sphere, we does not show the homoleptic heteroleptic because this is not ligand. Okay, inside big bracket, as we know, one is central metal atom, and this central metal atom is surrounded by all 6 ammonia. The ammonia is same, all 6 ligand are same. The answer is D, because all ligand are same. If all ligand are same, the compound is homoleptic complex. Okay, now if we see next question, question number 3, the correct name of the reaction Rx plus NaI give Ri plus NaX. As we know, there are two type of halogen exchange reactions are given in our syllabus. One is Finkelstein reaction, other is Schwarz reaction. In Schwarz reaction, exchange of fluorine will take place. In a Finkelstein reaction, exchange of iodine will take place. Okay, here exchange of iodine is taking place. That's why answer will be Finkelstein reaction. In Wood's reaction, two Rx join together. Okay, Schwarz reaction, exchange of fluorine will take place, not iodine. Fiddlecraft substitution of benzene derivative. Okay, aromatic compound. Now answer will be first Finkelstein reaction. If NaI-acetone will come, answer will be Finkelstein. Now chemical formula of Hinsberg reagent. Hinsberg reagent chemical formula. Chemical formula of Hinsberg reagent is benzene sulfonyl chloride, which is used to distinguish primary, secondary, and tertiary amine. The answer will be benzene sulfonyl chloride. Actually, is benzene sulfonyl chloride. Structure of benzene sulfonyl chloride: benzene S double bond O Cl. If you see C6H5 SO2 Cl, C6H5 SO2 Cl. Answer will be C. Okay. Now, if you see question number 5, in question number 5, it is given that doctor advised a 50 years old woman enough exposure to sunlight and addition of fish, exposure of sunlight, addition of fish and yolk to her diet. Name the vitamin deficiency for the possible disease diagnosed by the doctor. What type of deficiency are present in the women are diagnosed by the doctor? Now see, if doctor advised to go inside the sunlight, that indicate there is a deficiency of vitamin D, because from sunlight we get vitamin D. Answer will be, and some type of rickets type of disease were identified by the doctor. Answer will be A. Okay. Now answer of question number 5 is A, vitamin D. Now if you see question number 6, in question number 6, salicylic aldehyde can be prepared from which of the following reactant? Salicylic aldehyde can be prepared from which of the following reactant? Now the answer, this is actually salicylic aldehyde preparation is by Remer-Tiemann reaction. Remer-Tiemann reaction. Now Remer-Tiemann reaction, what happened? Phenol react with chloroform. Phenol react with chloroform, CHCl3, to form salicylic aldehyde, OH and C double bond OH. This is phenol plus chloroform. Answer will be A. This reaction name is Remer-Tiemann reaction. Important name reaction. Okay. Now see next question. Major product formed in the following reaction is, what is the major product formed in the reaction? Here reactant are given, some alkyl halide react with alcoholic QH. What is the function of alcoholic QH? Alcoholic QH act as eliminating reagent. Elimination reactions will take place here. If aqueous QH are given, then substitution will take place. Here alcoholic are given, that means elimination reaction will take place. And how the elimination reaction will take place? This bromine eliminate with this hydrogen or this hydrogen. These two product will form. One will be major and other will be minor. We have to give answer according to major. Here given major product. So two type of alkene will form here, because this bromine eliminate with this hydrogen, the formation of CH3, CH2, CH double bond CH2. One product is this, and another product is if bromine eliminate with this hydrogen, then formation of CH3, CH double bond CH, CH3 will take place. Okay. Now if you see which of them out of these two product, which one is major and which one is minor, we will decide according to alpha hydrogen. Maximum the alpha hydrogen, maximum will be the major will be the product. Here if we see the alpha hydrogen of this alkene, here these two carbon contain double bond. Now alpha hydrogen is 2 alpha hydrogen. Here how many have alpha hydrogen? This is alkene. This alkene also contain 3 alpha hydrogen, and here also 3 alpha hydrogen. Total 6 alpha hydrogen. 6 alpha hydrogen. 6 alpha hydrogen, that indicate this will be major alkene. Answer will be but2-ene. But1-ene, no. But2-ene. But1-ene minor. Answer. The question asks major product. Major product is but2-ene. Answer will be D. Okay. Now, if we see next question is question number 8. In question number 8, if you see in question number 8, the first statement is, in benzylic alcohol, the OH group is attached to sp3 carbon atom next to aromatic ring. Yes, it is correct. What is benzylic alcohol? This is actually benzylic alcohol. This is benzene, and this benzene attached with this carbon, and this carbon with OH. This carbon contain H. This is benzylic alcohol. Yes, this carbon is sp3 carbon, and this carbon is sp3. The OH contain next to the aromatic ring, and carbon is sp3. Now second statement is, the vinylic alcohol, the OH group is bonded to the carbon atom of carbon-carbon double bond. Vinylic alcohol, if you see vinylic alcohol, carbon-carbon double bond, and one carbon get OH, here H2. This is also correct statement. Vinylic alcohol is the alcohol present on carbon-carbon double bond. Both statement 1 and 2 are correct. Answer will be A. Okay. Now, if we see question number 9, in question number 9, it is given, question number 9, it is given that 2A plus 3B plus half C give product. The correct order of the reaction is, if is see here, if we apply the rate expression, what is rate expression actually said? Actually, if we apply in this reaction rate expression minus, how can we apply? That is minus in the reactant side minus and product side plus, minus dA upon, sorry, 1 by 2 dA upon A is equal to minus 1 by 3 dB upon dA upon dt, dB upon dt is equal to minus 1 by 1 upon 2 dC upon dt. Now, what the answer we get? Minus dA upon minus 1 by 2 dA upon dt is equal to minus 1 by 3 dB upon dt is equal to minus 2 dC upon dt. Okay. Now, if we rearrange this, as you know, here all the option contain minus dA upon dt. So we can multiply this. If we can send this to this side. Okay. What we can? Minus dB upon, sorry, minus dA upon dt is equal to, if you put this to in this side, what we get? Minus 2 upon 3 dB upon dt is equal to minus, if you multiply this 2 by this 2, what happens? Minus 4 dC upon dt. Now, answer will be, which option matches this? Answer will be minus d upon dt minus 2 by 3. Answer will be A. Okay. Now, answer of question number 9 is A. If you see question number 10, in question number 10, simply in question number 10 it is asked, question number 10, lambda m molar conductivity, the unit of molar conductivity is Simon centimeter square mole inverse, mole inverse. Okay. E cell is actually potential D, K is Simon centimeter square and G is centimeter inverse. Okay. Now, answer will be AC 2D, AC 2D, AD no, AB no, AC 2D, both option, and 3A, 3B no, 3A correct. Answer will be B. Okay. Now, next question is question number 11. In question number 11, it is asked that hydration of acetylene, that is ethine, with dilute H2SO4 and HgSO4 gives what the product form. If you see ethylene, ethylene, that is CH, CH. Now, in first, if we add HgSO4 and HgSO4 and H2SO4, first product will be vinyl alcohol. First product will be vinyl alcohol, CH2, CH, OH. If we tautomerize this, tautomerization. If you tautomerize this, now the formation of acetaldehyde will take place, CH3H. This acetaldehyde will take place. Answer will be acetaldehyde or ethanaldehyde. Answer will be C. Okay. Next, if you see question number, after question number 11, question number 12 and 13. Question number 12, if you see, the question number 12, 10 ml of A and 20 ml of B, means A plus B, it is given 10 ml A and 20 ml B. Mixed at 25 degrees Celsius, the volume of solution was measured 30 point. If we add this 10 and 20, we got 30, but the answer is 30.1. 30.1 ml of mixture of A and B will form. That indicate del V is greater than 0. Del V greater than 0. If del V is greater than 0, that indicate reaction is positive deviation from Royle's law. That is positive deviation from Royle's law. From Royle's law. If it is positive deviation from Royle's law, then del H is also greater than 0. Del H greater than 0. Answer will be del H less than 0. No. Del H less than 0. No. Del H greater than 0. Yes. So negative deviation, no. So positive deviation from Raoult's law. Answer will be C. Okay. Now, if we say arrange the following complex in increasing order of crystal field ligand. Crystal field ligand increasing order. Now see here, Cl is weak ligand, Cn is a strong ligand, and Cf is weak ligand, Cn is a strong ligand. Now answer will be Cn, then H2O, then halide. Answer will be A. Okay. Now after that, question number 13. If we see by electrochemicals, you can determine this. Question number 13, question number 14, and question number 15. Okay. Now see question number 13. A binary mixture has two components A and B. The mole fraction of A is 0.5. Mole fraction of A is 0.5. Then the number of mole of A and B in the solution is, if mole of A is 0, that indicate 0.5 means half, that indicate Na upon Na plus Na plus Nb is equal to half. That indicate Na plus Nb is equal to half. Now how can we write this? Na, if we put this to here, this side, 2Na is equal to Na plus Nb. From here, if we put this in left hand side, what we get? Na is equal to Nb. Answer will be Na is equal to Nb. Answer will be C. Okay. Now after question number 14, if we see question number 15, the reagent which is used, which does not react with both acetone and benzaldehyde, which does not react with acetone and benzaldehyde. Actually, the fairing tests are not given by the tests are not given by the acetone, that is ketone, and benzaldehyde also does not give this test. Answer will be fairing solution. Okay. Answer of question number 15 is C. Let's start question number 1. It is given that mass percentage W by W of glucose is in water is 10%. Mass percent W by W, that indicate 10% W by W indicate 10 gram of glucose dissolve in 100 gram of solution. 10 gram of glucose dissolved in 100 gram of solution. Then how much water will be in 100 gram of solution? How much water? Then this is solution. Solution is solute plus solvent. As we know, solution is 10 gram. Solution given 100 gram. And solute is 10 gram. Solute is 10 gram. What is the mass of solvent? Solvent is equal to 100 minus 10, that is 90 gram. Solvent is water. 90 gram water, that indicate 10 gram of glucose dissolved in 90 gram of water, because this is given in term of water. This is not 100 gram of water. 100 gram of solution. 100 gram of solution means how much water? That is 90 gram of water. Answer will be D. Okay. Now answer of question number 1 is D. Now if we see question number 2, in question number 2, which of the following element is liquid at normal temperature? Which of the following element? In this question, there is question inside question is element. Which of the following element is liquid in room temperature? Most of the students confuse that, because water, as we know daily life, water is in liquid form, but water is not an element. Water is a compound. H2O is a compound. Water is also a liquid. As we know, water is a liquid, but water is not an element. Water is a compound. Okay. Which element? The question is, which element is liquid? Zinc is not. Zinc is also element, but it is not liquid. It is solid. Aluminium is also an element, but it is solid at room temperature. But mercury is an element which is liquid at room temperature. Answer will be B. Okay. Answer of question number 2 is second. Now, reagent used in Sandmeyer reaction. Sandmeyer reaction में which reagent is used? CO2, Cl2 and HCl. Obviously simple. Now, the next question is the main natural source of acetic acid. Which is the main natural source of acetic acid? In milk, there is lactic acid will present. Red and formic acid. Butter, butyric acid. In vinegar, acetic acid is present. Okay, ethanoic acid or acetic acid. Okay. Common name is acetic acid and IPAC name is ethanoic acid. Answer will be B. Now if we see question number 5, reaction of aniline which produce deuter ion major product. Deuter ion, if it react with highly acidic highly most acidic compound, that will form deuter ion. Dinitration, direct nitration, no. Bromination, no. Sulfonation, in case of sulfonation, deuter ion will form. NH3 plus and SO4 minus will form. The deuter ion will form in sulfonation. Next, if we see question number 6, method used to separation of isomeric product obtained when phenol react with dilute HNO3 at low temperature. As we know, if phenol react with dilute HNO3, the product will form dilute HNO3. The product will form O-nitrophenol or dinitrophenol. If phenol react with, this is phenol. If phenol react with HNO3, then O-nitrophenol or P-nitrophenol will form. This is OH, this is O-nitrophenol, NO2, and plus P-nitrophenol. P-nitrophenol means OH, here NO2. NO2 in para position, NO2 in ortho position. These two products will form. But how can we separate this ortho and para position? By steam distillation. By steam distillation, not sublimation, electrolysis or definition. By steam distillation, we can separate this ortho and para, because this form hydrogen bond, this form intramolecular, this form intermolecular hydrogen bond. So boiling point will be different. So we can separate by distillation. Now after question number 6, if we see question number 7, in question number 7, the ligand which form more stable coordination complex out of electrochemical series, out of the series of the ligand which is more stronger ligand, we can identify which one form the more stable coordination complex. Okay. Now in the series of the ligand, we know the most powerful ligand is Cn minus. That's why answer will be C. Okay. Now because this is weak ligand, this is weak ligand, this is water is also weak ligand, and these two are strong ligand. NH3 and Cn minus are strong ligand. Out of these two, Cn minus is more stronger than NH3. Okay. Now you can see directly from the notes. Which of the following group when present at para position increase the basic strength? As we know, basic strength are increases by plus M effect or plus I effect, and minus M and minus I decrease the basic strength. Okay. Now how can we identify this? Which of the following group present at para position increase the basic strength? As we know, NO2, in case of NO2 and double bond directly attach and double bond O are present. If double bond directly attached compound contain double bond, that's so minus M effect, that's so minus M effect as well as minus I effect. This bromine so plus M as well as minus I effect. In case of halogen, I is stronger than M, that's why minus I is dominating over plus M. Okay. In case of NH2, plus M and minus I will act, but plus M is very stronger in case of NH2. In case of COH, minus M will decrease the basic character. This will also decrease the basic character. This will increase and this will increase. But here minus I is more as compared to plus M. Here plus M is stronger. That's why answer will be C. Okay, because here acidic character will be more. Here basic character will be more. Now after question number 8, if you see question number 9, in the following acid vitamin is, which one is vitamin? Adipic acid, aspartic acid, saccharic acid? No, ascorbic acid, that is vitamin C. Ascorbic acid is vitamin C. Okay. Now after question number 9, we see question number 10. The best reagent useful for separation and purification of aldehyde from ketone. Aldehyde from ketone. Toluen reagent also used for the separation of aldehyde and ketone. We can distinguish aldehyde and ketone by toluen reagent. Sodium hydrogen sulfide. Yes, by this we can also separate the aldehyde and ketone. because aldehyde and some of the ketone also show reaction with this, but most of the ketone will does not react with sodium hydrogen. 2,4-DNP, both aldehyde and ketone will give the 2,4-DNP. That's why we cannot determine with 2,4-DNP. Answer will be Tolan reagent. Tolan reagent always the which compound will give? Aldehyde will give only the Tolan reagent test, but ketone will not give Tolan reagent test. But purification, if said purification, that then answer will be sodium hydrogen sulfide. If in question it was given, how can we distinguish aldehyde and ketone? Then answer will be Tolan reagent. But the question are given separation or purification, then sodium hydrogen sulfide is right answer. Okay, the answer will be B. Next, after question number 10, if you see question number 11, in question number 11, if on mixing the two liquid, the solution become hot, it implies that it show negative deviation from Raoult's law. If mixing of two liquid, if solution become hot, that indicate heat is released. If heat is released, then delta H is equal to negative. Delta H negative means delta H less than 0. Delta H less than 0. Delta H less than 0. Negative deviation from Raoult's law. Yes, this is right statement. First statement is correct. Now, if you see the second statement, in statement second, solution which show negative deviation are accompanied by decrease in volume. In negative deviation from Raoult's law, there will be less than 0. Yes, both statements are correct. So statement 1 and 2 are true. Okay. In question number 11, both statements are true. Okay. Now after question number 11, if you see question number 12, in question number 12, match the following transition metal compound with their catalytic activity in the corresponding process. Now, this is TiCl4AlCS3 whole thrice. This is Ziegler-Natta catalyst. Ziegler-Natta catalyst used in industry for making polythene, manufacture of polythene. Answer of A is C. Now, if you see PDCl2, PDCl2 is Wecker process, used in Wecker process for formation of ethanol. Next is Ni, PD and PT, used in hydrogenation of unsaturated to a saturated compound. Okay, hydrogenation of fat. Next is V2O5 vanadium pentoxide in contact process, used in manufacture of sulfuric acid. Now answer of A is C, 2 is A, C, 2A, 3D and 4B. Answer is A. Okay, answer of question number 12 is A. Now after 12, if you see question number 13, 14, 15. 13, 14, 15. Okay. Now, in question number 13, cumene hydroperoxide on hydrolysis on dilute acid give. Actually, you know, this reaction is industrial method for preparation of phenol. In NCERT already given industrial method for preparation of phenol, that is from cumene. Cumene is benzene content CS3, yes, CS3. If you react with hydrogen peroxide H2O2, then formation of phenol plus acetone will take place. Phenol plus acetone. Acetone, that is CS3, C double bond O, CS3. Answer will be phenol and acetone. Answer will be D. Okay, this will answer the question. Now, among the following cell, the cell used in Apollo space program for providing electric power is this. Which type of cell is used? H2O2 fuel cell, hydrogen oxide, H2 hydrogen and oxygen fuel cell used in space. Okay. Now, if you see question number 15, this is important question and a good question. How can we identify in question number 15, the following result have been obtained during the kinetic study of reaction A plus to B give C. Actually, we know this is not a simple reaction or elementary reaction, so we cannot directly apply the law of mass action. We can calculate the order of reaction by using the experimental data. Now, how can we solve? See, This is very simple question. If you know how to solve this question, see, how can we solve? If we calculate the order with respect to A, if we calculate order with respect to A, then take the concentration of A different and B same. In which condition, in which experiment, A concentration of A is different, this and this are same, so we cannot this two. If we take this same, then in with respect to A, we cannot determine the order of reaction. These two are different. Now we take these two and B will be same. Then we calculate the order with respect to A. Now how can we determine with respect to A? So यहाँ पे write down order with respect to A. How can we determine? Divide equation experiment 4 by 2. If we divide 4 by 2, what we get? 0.4 upon 0.2 to the power A. To the power A. A is order with respect to A. Now into here is 0.3 upon 0.3 to the power B is equal to, what is the rate of formation of C? 2.8 into 10 to the power minus 1 upon 7.2 into 10 to the power minus 2. Now what is the answer we got here? 1 to the power anything will be 1, this will be 1, and here we got 2 to the power A. 2 to the power A into 1 is equal to 2 to the power A, and here we got, if we put this point here, this will be minus 2, this will cancel out and it will cancel out in 4 times. This is 4. Now what can we write? 2 to the power A is equal to 2 to the power 2, that is A is equal to 2. That is order with respect to A is 2. Order with respect to A is 2. In only one option order with respect to A is 2 is given. We can calculate order with respect to B also. How can we calculate order with respect to B? Take the experiment which contain different B and same A. Which contain different B and same A? These two contain same A and different B. Now divide equation 3. Now and another experiment, divide 3 upon 1. 3 upon 1, what we get? 0.1 upon 0.1 to the power A into 0.4 upon 0.1 to the power B is equal to 2.4 into 10 to the power minus 2 upon 6 into 10 to the power minus 3. What we got here? If we remove this point, it becomes 10 to the power minus 3. This will cancel out. This cancel out in 4 times. Now this will cancel out 1 to the power anything will be 1, and this will be 4 to the power B. 4 to the power B is equal to 4. 4 to the power 4, we can write 4 to the power 1. If base are same, then power will also be same. B is equal to 1. With respect to B, order is 1. With respect to A, order is 2. Answer will be C. Okay. Hope you got the answer. And this is all we have discussed. I have already discussed all these 3 model question paper MCQ. Hope you got understand, and maximum question, I hope maximum question around 10 question or more than 10 question directly will come from this model paper. Okay. First question is the mixture of which shows the positive deviation from Rolle's law. Which show positive deviation from Rolle's law among these 4 options? First option is N-hexane and N-heptane. This N-hexane and N-heptane follow ideal. This is ideal solution. Does not and positive and negative deviations are shown by non-ideal solution. This is example of ideal solution. Okay, so this will not be our answer. Bromomethane and chloromethane, this will also negative deviation. Chloroform, if chloroform will come in an option, that will show negative deviation from Rolle's law. And ethanol, if ethanol come with any of the compound, any of the mixtures, that will show positive deviation from Rolle's law. The answer of this question, first question will be C. Answer of first question will be C. Now, if we see the second question, the cell that convert energy of combustion of fuel like hydrogen and methane directly into chemical energy. So which type of cell convert directly hydrogen and methane directly into electrical energy? This type of cell actually S2 and O2. This is in your syllabus, S2 plus O2, and which oxidize any of the organic compound like methane. And this type of cell belongs to fuel cell. In your syllabus, there is a fuel cell which comes. This is very important cell. Okay, for your board examination. Now, next question is common name of ethane dioic acid. What is the common name of ethane dioic acid? You know what is ethane? Ethane is, eth means two carbon. There is two carbon, that means eth. Eth and dioic acid. And N means carbon carbon single bond. Dioic means both carbon containing carboxylic acid group. Both carbon containing carboxylic acid group. This is ethane dioic acid, and the common name of ethane dioic acid is oxalic acid. What is the common name of ethane dioic acid? That is oxalic acid. Now, what is acetic acid? Acetic acid is common name of ethanoic acid, not ethane dioic acid. Di means two acidic group. Acetic acid means ethanoic acid that contain one group. If you see the structure of acetic acid, this is like that: CH3, C double bond O, OH. This is acetic acid. Now, if you see the adipic acid and succinate, if you want to see the dioic, these two belongs to dioic acid, but not ethane dioic acid. How can you memorize this type of dioic acid? Like Ohm's gap. Ohm's gap. Okay. Now, Ohms means two carbon, that is oxalic acid. Two carbon oxalic acid, and three carbon malic acid, four carbon succinic acid, glutamic acid, adipic acid. Adipic acid means 4, 5, 6 carbon. So, this is hexane dioic acid, and succinic acid is butane dioic acid. This is hexane dioic acid, and this is butane dioic acid. Now, ethane dioic acid is oxalic acid. Answer will be B. Okay. Now, if we see next question, question number 4. Question number 4, aldehyde which do not respond to Fehling test. Which aldehyde do not respond to Fehling test? Actually, aliphatic aldehyde give the Fehling test, but aromatic aldehyde do not give Fehling test because Fehling solution is weak oxidizing agent, and if aromatic aldehyde come which contain electron withdrawing group, and electron withdrawing group does not allow to oxidize the compound. That's why answer of this question will be all are this formaldehyde is aliphatic aldehyde, ethanol is also aliphatic aldehyde, and benzaldehyde is not aliphatic aldehyde. This is aromatic aldehyde. You know benzaldehyde, benzene group contain aldehyde. This is benzaldehyde. Okay. Now here aromatic aldehyde come, that indicate this compound will not show Fehling test. Okay. Answer will be C. Now, if you see question number 5, in question number 5, pKa value of phenol, O-cresol and O-nitrophenol are given. pKa value are given as we know, and the question asks correct order of acidity. What is the correct order of acidity among them? The value of pKa given 10.0, 10.2, 7.2. This is the pKa value of phenol, O-cresol, and O-nitrophenol. Okay. Now, the correct order of acidity. As we know, acidity is inversely proportional to pKa. Acidity is inversely proportional to pKa and directly proportional to Ka. Directly proportional to Ka, inversely proportional to pK. Inversely proportional means more the pKa, less will be the acidity. Among them, maximum pKa value is O-cresol. So less will be the acidity of O-cresol. Last में कौन चला जाएगा? In last O-cresol. Then after pKa value is phenol. Then the acidic value will be phenol. And after that, maximum acidic character will be O-nitrophenol. The correct answer will be maximum O-nitrophenol, then phenol, then O-cresol. Answer will be D. And if it is not given, apart from that, you can solve this question like in O nitrophenol, minus M and minus I group are present. That's why it increase the acidic character. And in phenol, there is no minus I and minus M effect. Okay. And in O cresol, there is plus M effect. Plus M effect decrease the acidity. That's why less acidic will be O cresol. And in phenol, there is no plus I and minus I effect will act. And in O nitrophenol, there is minus I effect which increase the acidity. Answer will be D. Okay. Now, if you see question number 6, a student took 2 glasses of pure water from a water filter. He cools glass A in fridge and warm the glass B on stove. On comparing the solubility of oxygen in H2O water in glass A and glass B, state that the glass A contain. Okay. Now, there is a student. He take 2 glasses, glass A and glass B. He put this glass A in fridge and warm glass B on a stove. Okay. Now, answer is which contain state the glass A contain maximum oxygen than water, minimum according to the and we know that the solubility of gas, solubility of gas in a liquid inversely proportional to temperature. Inversely proportional to temperature means less the temperature, more will be the solubility of gas. Less the temperature. Now, gas A has less temperature because it is put inside the fridge. Inside the fridge, there is a less temperature. That's why glass A contain glass A contain more oxygen than glass B. Which answer will be correct? That glass A contain more oxygen than glass B. Answer will be first. Now, next question is question number 7. In question number 7, it is given that 2NH3 at 1130 Kelvin and the catalyst is PT, platinum, that is solid, give N2 plus 3H2. The rate of the reaction is, what is the rate of this reaction? Now, how can we solve these questions? Now, if it was given that this reaction is elementary or simple reaction, if it was given simple reaction or elementary reaction, then we apply the law of mass action and write that R is equal to K concentration of the reactant to the power coefficient. The answer will become R equal to K NH3 to the power 2. If it was given simple, then answer will be C. But here there is no uh, there is nothing mentioned here that this reaction is simple or elementary reaction. Okay. Now we cannot apply the law of mass action here. Then how can we solve this question? This is actually the example of zero order reaction. If you see the NCERT, and if you see NCERT here, one of the sentences mentioned that heterogeneous mixture, always heterogeneous reaction, most of the time follow zero order kinetics. This is heterogeneous reaction. Why? Because this reactant and product are in gaseous form, but catalyst in solid form. Both are different phase. Catalyst and reactant and product are present in different phase. That's why it is heterogeneous mixture. And heterogeneous mixture follow zero order kinetics. So the answer of this question will be R is equal to. Answer will be. How can we write? R is equal to K NH3 to the power, concentration of reactant to the power 0. Why? Because these reactions follow zero order kinetics. Now R is equal to K NH3 to the power 0, and what happened? R is equal to K and NH3, anything to the power 0 will be 1. So K into 1 will be K. So R is equal to K. Answer will be D. Answer of this question will be D. Okay. Now, if you see next question, question number 8, it is simple question. We have to only match the following. Now, in which we have to simple match in option first. It is given phosphodiester linkage. Phosphodiester linkage, as you know very well, it is present in the nucleotide and polynucleotide by forming the phosphodiester linkage from the DNA or RNA. Okay, and nucleic acid. Now, phosphodiester linkage present in nucleotide. Answer of first is B. Now, glycosidic linkage, as we know, glycosidic linkage is present in a sugar, as and the monomer of sugar is monosaccharide. Answer will be C. Now, peptide linkage actually present in protein, and monomer of protein is amino acid. So, option 1 matches with B. Option 1 matches with B in both C and D, and option 2 with C. Option 2 with C, both option, and option 3 with A. Here D, here A. Answer will be D. Okay, this will be correct answer. Answer D will be correct. Okay. Now, if you see question number 9, in question number 9, it is given that when an alkene react with a component X, when an alkene react with component X, in CCl4, reddish brown color of compound X disappear. Yield vicinal dihalide. Compound X is, what will be the compound X? Now see, actually reddish brown color are given, that indicate bromine must be present. Chlorine will not present, iodine will not present. And bromine, in these two cases, bromine are there. Here HBr, here Br2. Now see, if take an example of alkene. For example, this is CH3, CH double bond CH2. Now, if we react with HBr, if we react with, for example, HBr, and another we react with Br2. Now, product here, product 1 will gain, here product 2 will be obtained. Now, see what will be the product 1 according to Markovnikov rule. This is plus, this minus, and here plus, here minus. Now, formation of CH3, CH, CH3, and Br will take place. This is actually the right option? No, because here given the vicinal dihalide, here this is monohalide, this product is monohalide. Now if we put Br2, then if you break this bond, here plus minus, and Br2, one Br get here, one Br get here. This is CH3, CH, CH2, here one Br, and here one Br. This is dihalide, yes. This is vicinal dihalide, yes. Two Br present adjacent to each other, that's why this is vicinal dihalide. Okay. The answer will be Br2. Answer will be C. Okay. Now, in question number 10, it is given, first statement is potassium permanganate is powerful oxidant. Potassium permanganate is powerful oxidant. It is correct or wrong? Yes, it is correct. Potassium permanganate is very powerful oxidant, oxidizing agent. It also it react with alkene to convert into alcohol, and even primary alcohol to aldehyde and carboxylic acid. This is very powerful oxidizing agent. This is correct statement. Next is statement 2. KMnO4 oxidize I-3 to IO3 minus in acidic solution. No. In acidic solution, I minus is converted into I2. But if it is given in neutral medium, I minus into I3. Yes, in neutral medium, it convert I minus into IO3 minus. But in acidic medium, it convert into I2. The statement 1 is correct. Statement 2 is wrong. Statement 1 is correct, and statement 2 is wrong. Answer will be D. Statement 1 is correct, but statement 2 is incorrect. Okay. Now, if we see next question is question number 11. In question number 11, it is given. In question number 11, it is given that consider the given reaction RCONH2 plus Br2 plus NaOH give RNH2 plus Na2CO3. As we know, this reaction is Hofmann bromamide reaction. As we know, in Hofmann bromamide reaction, what happened? And here given that product formed, this RNH2 formed is CH5N. CH5N. That means this is NH2, and here this is NH2, and here CH3. This is your product. And we know in Hofmann bromamide reaction, there is leaving of CO group. This is RCO. This is RC double bond O NH2. In this RCO NH2, there is leaving of this group in Hofmann bromamide reaction. If we remove this, then formation of this compound will take place. Now, instead of R, what we will put? This CH3. This compound will be CH3, C double bond O NH2. If this compound will be NH2, if this compound will be here, then the formation of this compound will take place. Okay, now in Hofmann bromide reaction, this molecule will be eliminated and the formation of CH3 NH2 will take place. Now which answer will be correct according to this? Which answer will be correct? This is C2. How many carbon? C2. And how many hydrogen? 3 and 2, 5, H5 and 1 oxygen. C2H5, C2H5 and 1 nitrogen. C2H5NO, C2H5NO. Answer will be second. Okay, C2H5NO. One C, other C. C2H5NO. Answer will be second. Okay. Now next, if we see question number 12, in question number 12, it is given that MnCN whole 6 minus 3 and Fe F6 minus 3 are inner orbital. Option are given: inner orbital and outer orbital complex, both are inner orbital. Outer orbital and inner orbital, both are outer orbital complex. How can we solve this? Actually, this is a strong ligand. Cn minus is a strong ligand and F minus is weak ligand. If we apply the VVT here or CFT, either VVT or CFT you can apply, you will get this strong ligand do the pairing of the d electron, and this weak electron does not pairing the d electron. That's why here the inner orbital complex form and here outer orbital complex form. Then answer will be inner orbital and outer orbital. Let me explain with this. Okay, now this is 5 orbital. Here manganese, what is the oxidation state of manganese here? +3. How can we calculate? X minus 6 is equal to minus 3. X is equal to +3. Oxidation state of manganese is +3. And how many electron will be there in manganese? What is the electronic configuration of manganese? 4s2 3d 5. +3 indicate that 4 electron we have to remove. Answer will be 3d 4. Now put this 4 electron 1, 2, 3, 4. Now this pairing will take place. Now this the formation of inner orbital complex will take place here, and here the outer orbital complex will form because of because in case of Cn minus is a strong ligand, it will pair the d electron, but F minus is weak ligand. This does not allow to pair of the electron. Okay, now answer will be A. Now if we see the next question, question number 13. Triiodomethane are used earlier as an antiseptic. The antiseptic properties are due to the antiseptic property, as we know, due to the presence of I2. Iodine is actually act as antiseptic properties, behave as antiseptic. The liberation of I2. Answer will be liberation of I2. Presence of iodoform. No, this is also already iodoform. Objectionable smell. No, there is no role of smell. Presence of methane. No, answer will be liberation of I2. Okay. Next, if we see question number 14, electronic configuration of a transition element X is X in +3 oxidation state is 3d5. What is the atomic number? What is the atomic number? +3 means argon. Argon means 18. And here D, how many electron in D? 5. 18 plus 5, and +3 means 3 electron we have removed from the atom. Now if we put the if we take the atomic number, then we does not decide according to electron, we decide according to proton. The number of proton will be +3. The answer will be 5, 3, 8 or 18, 26. Option 26, option C will be correct. Okay. Now if we see question number 15, acetylation of salicylic acid produce a compound which has anti-inflammatory and antipyretic properties. The compound is actually, you know, this is salicylic acid. This is salicylic acid, C double bond O, OH, and this is OH. If we if we do the acetylation of the salicylic acid, like CH3, C double bond O, Cl. This is acetylation. The formation of this compound will take place. This is C double bond O, OH, and O, C double bond O, CH3. This is acetylation of salicylic acid, and this compound is known as aspirin. Aspirin, as we know, aspirin is used as antipyretic, and major component of paracetamol? Answer will be aspirin. Okay.